So now we're going to construct our bending moment diagrams, and we have already calculated the reaction forces in our previous video. So if you don't know how to do that, you can go ahead and watch that video first. And then the second thing that we did was to construct our shear force diagram. And this is the final of the three-part series where we're now going to construct our bending moment diagram for this beam. So the first thing that we need to do is to then calculate our bending moments. And we're going to go from left to right. And for this one, I'm going to use this blue highlighter to indicate exactly where on the beam I'm at. So let's begin. And the first bending moment we're going to calculate is right there at 0 meter mark. And our bending moment at 0, when we do our force times perpendicular distance, that is simply going to be 0, because our distance to begin with is 0, and also the force is acting through the exact pivot point. So from our previous video, you would have learned that that's always going to be 0. So now we're going to go across to the next point, and that next point is our 5 kilonewtons mark right there, where I'm drawing that blue highlighter. And we're concerned with everything that's happening left of that mark. And to the left of that mark, what we have reaction A, and we also have that UDL that spans across 4 meters. So we're going to now calculate the bending moment for that. So let's do that. So our bending moment at 4 meters. So what that looks like. So the first thing I'm going to look at is how to treat that UDL and what that looks like. So for our UDL, what we have is 4 meters as our length, and the UDL spans across 4 meters, and it's 2 kilonewtons per meter. So that's 4 times 2 right there. Now the UDL in this instance, it will be acting at 2 meters because that's the midpoint of that 4 meter mark. So as a point load, we're going to have 4 times 2 and then times 2 again. And the reason for the second times 2 is because that's going to represent exactly where we're going to place the UDL, which is at the 2 meter mark. So now our UDL as a point load is 4 times 2, that's our 8, and times 2, that's our 16 right there. So 16 kilonewtons is our UDL as a point load. So in terms of the bending moment now, at that point, all we're gonna do here is our reaction force, which is 32.06 multiplied by the distance of that reaction force to our blue line, which is times 4. And what we're going to subtract now is the UDL that we just calculated, which is our 16 kilonewtons right there. So when we do 32.06 times 4 and minus our UDL, so that looks like 128.24 minus our 16, and we are left with 112.24, and that's kilonewton meters. So that's the first UDL mark. So we are now going to go across to the next force there, and that's at the 19 kilonewtons mark right here. And once again, what we're interested in is everything that's happening to the left of that 19 kilonewtons. So for our calculations now, so bending moment at, in this instance, that's at 9 meters. So what we have then, I'm going to just do the all-out calculations now. So bending moment is equal to, so the first point that we have, or the first force, is our 32.06, and we're multiplying that reaction force times that distance right there, which is our 9. So 32.06 times 9, and that's the distance of the reaction force. I'll just draw that for you in green so you can see. So it's the distance of this reaction force all the way to that pivot point there. So that's our perpendicular distance there. And then now we go across now, and this time around our next force is 5 kilonewtons. And our distance of the 5 kilonewtons to that same pivot point is 5. So we are going to have now 5 multiplied by 5. So notice now, I'll draw in green again, that distance there is shorter. So it's not the same as our reaction force distance, because it's the distance of the force to that blue line that we're looking at. So that's 5 times 5 there. So we go across then to the UDL now, and for the UDL, what we have, so we have 9 meters, so that's the length, so that's 9 for the length. And the UDL, 2 kilonewtons per meter, so that's 9 times 2. And what we have to do now, we have to place the UDL in the middle of that length 9. So that's why we're now going to multiply by 4.5, because we're going to times by half the length that the UDL spans across. Let's get those values. So we have here 288.54 minus 25 minus 4.5 times 2, 999 is 81. And what we're left with is 182.54. There we go. So we only have 2 more calculations before we finish our bending moment calculations. And the next one is at our 14 meter mark. So now bending moment at 14 meters, and I'll just switch between the colors. So we're doing bending moment at 14 meters. So let's just see what will be happening now at 14 meters. So we're going to look at, once again, everything to the left of the 14 meter mark, and that 14 meter mark is right here, right where that 3 kilonewton force is acting. And to the left, we have our reaction force. We have the 5 kilonewtons, the 19 kilonewtons, and our UDL. So let's go ahead and do the calculations for that. So this time around, you will notice that our reaction force, the distance keeps increasing. So this time it's at times 14. That's the length. Then now minus, so what we have here, so we have now 5 times 10 there for the 5 kilonewtons, and then we would have 19 times 5 for that 19 kilonewtons. Once again, let's look at that UDL and ensure that we completely get it on this one. So this is where we're at that 3 kilonewtons mark right there. And UDL is going to span across 14 meter. So it's 2 multiplied by our length, which is 14. And then that same length, we're going to half it. So that's where we put the UDL as a point load. So times, now half of that 14 is 7. So that's now 28 times 7. So hopefully that clears things up fully for how we treat the UDL. And then we just go across now to the next few loads. So the next one would be that 5 kilonewtons, and it would be at the 10 meter mark. And then the next one would be that 19 kilonewtons, and it would be at the 5 meter mark. And all we have to do is work these out. So what we have now, we have 448.84 minus 196 minus 50 and minus 95, and our total is 107.84. that's kilonewton meter. So we have one final point, and for this one I'm not even going to do the calculation. It's the bending moment at our 18 meter mark. And because our beam is a static system, then when we come to this end point and we do all the calculations that we have just done, then we expect to get a final answer of bending moment there equals 0. That's kilonewton meter. And you can do that calculation if you want, just to prove that you will get 0. So that's a handy one for you to do since you already know the answer. So what we do with all of this now, we are going to plot our points and draw our bending moment diagram. And I'll show you what it looks like now. So here we have our bending moment diagram ready to go. And let's just go ahead and do it. So the first point will be 0, 0. So right there at the origin. And then we're going to go across to that 112.24. So it's just an estimate I'm doing here. So that's round about it, 112.24. We then go across to 182.94. It's at 9 meters. So like so. Back down now to 107.84. And finally back to 0. And as always, if you want, you can just shade in some bits, but much tidier. So that's it. That's us calculating the reaction force, and that's us doing the shear force diagram, and now the bending moment diagram. And that's it. So I'll see you in the next video.